curious, engaging. When we peel back the textures, colors, and shapes of things we can touch, what is the actual fabric of the universe made of? Thousands of years ago, ancient Greek and Indian philosophers proposed a framework called the Panchtattva. They categorized all physical reality into just 5 basic elements: earth, fire, water, air, and sky. Without microscopes or chemical labs, these thinkers relied entirely on naked eye observation. If you can only study how things feel, flow, or burn, grouping the world by these highly distinct physical states is a strictly logical deduction. Early humans logically categorized the universe to make sense of the chaotic physical phenomena they interacted with every day. But what happens if you push past what the eye can see? Imagine taking a physical object, like a stone, and cutting it in half over and over again. Maharishi Kanada realized matter cannot be divided infinitely. Eventually, you hit a physical limit, a piece so small it resists breaking further. He named these tiny building blocks a small particle was an anu, and the ultimate indivisible unit was a parmanu. Kanada accurately predicted the particulate nature of matter entirely through logical deduction, centuries before the invention of the first magnifying lens. These ancient thinkers lacked technological tools, yet their immense power of philosophical reasoning laid the theoretical groundwork for modern physics. Eventually, human tools improved enough to move from passive observation to active experimental testing. This new testing revealed anomalies the ancient 5-element model couldn't explain. For example, 2 completely distinct substances, solid iron and invisible air, could combine to create an entirely new substance, rust. Or consider water. Long considered a pure, fundamental element, experimental chemistry proved it could practically be broken down into 2 distinct gases, hydrogen and oxygen. These chemical changes proved the 5-element model was functionally broken. It could not account for this new data. When a perfectly logical theory fails to explain new experimental evidence, the scientific method demands a shift to a new model. The modern scientific era answered these anomalies with the atomic theory of matter. Scientists defined the atom as the fundamental, scientifically measurable building block that makes up all physical matter. When different atoms bond together in specific combinations, they form a larger structure called a molecule. Rearranging these same fundamental bricks creates entirely new substances. This finally solved the mysteries of rusting iron and splitting water. While Kanada's anu was a brilliant philosophical guess, the modern atom is an empirically proven, measurable entity that allows us to directly manipulate chemistry. Even after proving the existence of the atom, the theory did not stop evolving. Scientists kept testing. J.J. Thomson proved the atom wasn't a solid, indivisible block, but contained internal negative charges. Ernest Rutherford's experiments showed that atoms are mostly empty space surrounding a dense central nucleus. Niels Bohr then realized that electrons travel in highly specific orbital paths around that nucleus. Based purely on new experimental data, the model rapidly transitioned from a solid sphere to a nucleated atom to complex orbits. Science is inherently progressive. No model is sacred, and every theory is subject to revision the moment better evidence is discovered. Looking at the ancient elemental framework next to the modern atomic framework, we see they are part of the exact same human pursuit. The ancient model was simply an incomplete picture, constrained by the limits of human sight. Ancient thinkers asked the exact right questions, while modern scientists utilized rigorous experimentation to find the answers. Human progress requires both the philosophical imagination to ask what if, and the experimental rigor to prove it. And with our tools constantly improving, we have to wonder what invisible mysteries of matter future scientists might uncover next.